Uh, this is Professor Prashant Mure recording live for Relative, that's RELA.TV. Today we are going to see a little bit about probability basic concepts, and we'll revise in that process basic Venn diagrams, the Boolean operation on multiple events. Uh, this problem is solved on the website, so which is under let's say quantitative analysis, and then you can go to statistical concepts and probability basic concepts. We have the notes here, and the problem code is CC201. If you'd like to pause the video and go through the problem statement, you can do that right now. I'll keep it on the screen. Um, Even though the problem is completely solved on the website, which I highly recommend to visit, we are going to solve that just to see some basic key concepts. So let's start right away. There is a shareholders meeting, and obviously you can participate in that meeting if you own. There are one of the two companies. One is Relative, that's RELA.TV, that's our company, and FEsuccess.com, which is our parent company. So if you own one of the company's shares, either one of them, then only you can participate into that meeting, in that meeting. Obviously, if you don't have any business with any of these companies, you are not invited. In that meeting, 65% of the participants own Relative shares, and 55% of the participants own FEsuccess.com shares. So the question here is, what percentage of people participating in that meeting own both company shares? That means they own Relative as well as FEsuccess.com. So let's see how we can solve this. We will use Venn diagram. Um, when we draw a Venn diagram, uh, the sample space, which is like the set of all possibilities or everything which is under consideration, is represented by a rectangle. Here, the number of people would be your sample space. An event is something which we conduct an experiment, or if you consider a specific part of that sample space. So here we are going to represent um, the people who own Relative shares by a circle, and let's call them as A. And let's draw another circle representing the people who have FEsuccess.com shares. Obviously, these two circles can overlap. That means there will be people in the meeting who can own both company shares. If for some reason, if you own company A shares and that prevents you from owning company B share, then these two circles will be totally separate. So in that case, I will draw and erase this one. In that case, the two circles will be separate. There is no overlapping area. In that case, these events will be referred as mutually exclusive events. So that's not the case right now. So let's get rid of this thing. We actually have a certain percentage of overlapping area, and that's what we are interested in. The thing here, for example, I have shown here the diagram. It says there is nobody in this area. If you do not own any of the company shares, you cannot participate in that company. So this is something interesting. For this particular situation, the area, which is like probably I can this everybody here and like okay, there is nothing there because obviously there is no fraction of sample space. There are no people who do not own any of the company shares. So that's in probability, this is like a empty set, null set, or you can represent it by a phi, which is basically empty. Now, So that means if this is a sample space and it represents 100%, so now I can safely say that this whole thing is actually 100%. So this is actually 100% because there is nobody outside that particular area, outside the two circles and still within the rectangle. There is no such thing, at least for this particular situation. Now, if you start counting, if you start adding the area, this area which I have shown you as shaded, this area is actually made up by. We can calculate that by adding this area. Let me make this a little bit smaller. Say, for example, there is another circle plus second area. Again, there is like the first circle. So you can add these two elements. The problem is, since there is an overlapping portion, so that particular common area is going to get counted twice. So that means we have to subtract. So now let me draw this a little bit dotted in the sense. So this area we have to subtract because like when you add the individual circles, the common area will be simply get added twice. We know that this is 100%. This is 100%, and this is like A. This is B, and this is actually A intersection B, which is the common area between two circles. And then with that notation, this is A union B. So now the things are clear. This is 65%, this is 55%, and then this is the area which we want to calculate. We can simply do the simple arithmetic and find out the common area, which is comes out to be around 20%. And the answer will be D. That's all for the timing. Thank you very much.